Okay, so for our fourth problem, another two-parter, we have Tiny, a 110-pound Great Dane, is being treated with heparin via IV infusion. You have a supply of heparin U1000, remember that means 1,000 units per milliliter, and you want to administer that at a rate of 200 units per kilogram of body weight for a 6-hour infusion and 1 liter of fluids with an IV calibration rate of 20 drops per milliliter. So that's a lot of information. We have the weight of the patient, we have the supply, we have the dose rate, we know how long the infusion is going to go, we know how many fluids we're going to work with, and we have our IV calibration rate. In the second sentence, we are told that the stop time for the infusion should be 3 p.m. And we are also given that another text that the observable drip rate is 60 drops per minute or 1 drop per second. So with this drip rate, if this is how the drip rate is set, when will the infusion actually finish? And based on what we see in part A, can we say the drip rate of 60 drops per minute was correct? So we have a lot going on here. So the first thing we need to figure out is how much heparin to add to the 1 liter of fluids. Because we want the total volume, right? We need the total volume to be infused in order to figure out how long it's going to take. So then the second thing we're going to figure out is the total infusion time. And in order to determine the total infusion time, of course, we need the total volume. So let's start with part A, which is how much heparin should we add to the 1 liter of fluids. So for part A, we are going to take our 110-pound Great Dane and do what we usually do. This is a straightforward drug dosage calculation. So the first thing we want to do is change pounds into kilograms, because we are going to give a dose at a rate of 200 units per 1 kilogram. All right, so our pounds go and our kilograms go. So right now, if we were to stop, we would know how many units to give, but we want to change units into milliliters. And given the supply information that U-1000, we know 1 milliliter of fluid or of solution gives us 1,000 units of heparin. So when we go through the calculations, we come up with just 10 milliliters of heparin to add to the 1 liter of fluids. So that's going to give us a total infusion volume when we take the 1 liter and add the other 10 milliliters of 1,010 milliliters. So that's what we're going to be infusing over the 6-hour period. Or that's what we want to infuse for what we hope will be a 6-hour infusion. But using the observable drip rate of 60 drops per minute, do we really cover the 6 hours? So what we're going to do is move to the next page and see what happens. So for part B, we know that we want to turn the 1,010 milliliters into some number of hours and minutes. Right? That's going to be our infusion time. So if we could figure out, using the other pieces of information, and what we're going to use here is that observable drip rate. Right, we're going to use the fact that it was set to 60 drops per minute. And we're also going to use the IV calibration rate of 20 drops per milliliter. And this is how we're going to get out of milliliters into drops and then drops into minutes. So we're going to go from milliliters to drops to minutes, and then to hours and minutes. Because once we have the number of minutes, we can certainly figure out the number of hours and minutes. So let's go ahead and start with the 1,010 milliliters. And the first thing I want to do is get rid of the milliliters and move into drops. So here's where my IV calibration rate comes in handy. I know that every 1 milliliter corresponds to 20 drops. So if I were to stop at this particular point, this would tell me all of the drops that are going to go through the IV chamber. But I don't want drops, I want minutes. So now, what I want to do is use the other piece of information that in 1 minute, there's a total of 60 drops, because that's how the observable drip rate was set. So when I do the calculations, this gives me a total of, we take the 1010 times 20, and that gives us 20200 over 60, and that's just minutes. So if we take 20200 and divide by 60, that comes out to be 336.6 minutes. And since we know every 60 minutes is 1 hour, what you end up with is 5 hours and 36.6 minutes. So that's basically 36 2/3 minutes. But that's clearly less than the 6-hour infusion that we would hope for. Oops. So based on this calculation, let me just put a little box up here. The actual stop time is going to be short of the 6 hours. So what we're actually going to do, or what we're actually going to get, is a stop time of about 2:36 in the afternoon. And so the drip rate was bad. The drip rate was too fast, because we ended up about 24 minutes before the stop time of 3 o'clock. If you hadn't figured this out by now, the start time should have been at 9 a.m., right? We were told it was a 6-hour infusion that should have stopped at 3 o'clock in the afternoon. So that must have meant that they started the infusion at 9 a.m. So if you start the infusion at 9 a.m. and the infusion goes for 5 hours and 36 minutes, then there you have 2:36 p.m. So the drip rate was too fast because we came up well short of the 3 o'clock desired stop time.